The Earth is 4.5 billion years old. Impossible for the brain to truly grasp. So let's do an experiment. Every second, about 1.5 million years pass. Imagine you're sitting on a train, looking out the window, and experiencing the entire history of Earth. You can let the video run in the background, study along with it, or simply enjoy the ride. From time to time, I'll say a few words. 4.5 billion years ago, right after its birth, Earth was a hell of lava. Pretty early in its history, Earth collided with a Mars-sized object called Theia, creating the Moon. Right now, it still looks huge. Over the next 100 million years, it will slowly shrink because it keeps moving farther away. 4.5 billion years ago, we are in the first eon of our planet, the Hadean, named after the Greek god of the underworld. The atmosphere is mostly CO2, and the ground is lava. We know very little about this period of Earth's history because almost none of it is left. 90 million years have passed. We're still in the lava hell phase. Make yourself comfortable. This is going to take a while. Hard to believe, but minerals called zircons were found that suggest there may have been some water at this time. During this phase, Earth and the inner solar system are shaken by heavy asteroid bombardment for several 100 million years. At this point, our sun shines 30% less brightly than today, but there are so many greenhouse gases that it's still warm and cozy. Around this time, life probably emerges. Only a few 100 million years after the beginning of everything, the first cells spread across our still very deadly planet. Earth continues to cool, and it probably rains for millions of years. Oceans form and cover the young planet with water. Hydrothermal vents that release hot minerals could have been the place where life originated, but we don't really know. We reach the Paleo-Archean. Most of Earth is still underwater, while the first supercontinents form in the depths. The days are shorter because young Earth is rotating faster. Nice that you're still here. You've already witnessed 1 billion years. Stromatolites still exist today from this time, sedimentary rocks built by microorganisms. They are among the first real pieces of evidence for life on Earth. Also, life begins to eat the sun. Photosynthesis may have started around here. 3.2 billion years ago, in the Mesoarchean, the age of continents begins. Tectonic plates collide, pulling and pushing deep into Earth, where they dissolve, the foundation for our modern continents. The oceans are over 40 degrees Celsius, as hot as a hot tub, and microorganisms spread everywhere. There are no plants yet to consume greenhouse gases, so it's really, really hot. In this atmosphere, you would die practically instantly. And there is still no oxygen. 2.8 billion years ago, the Neo-Archean begins. Earth is still a terribly hostile place, but thanks to plate tectonics, new materials are released from Earth's interior, giving life new things to build with. Sometime around now, prokaryotes like bacteria begin to colonize the planet. Life keeps diversifying, but it's still only single-celled organisms so far. 2.5 billion years ago, in the Siderean, a massive event is about to happen that will change the planet forever. The Great Oxygen Catastrophe. Oxygen, belched out by cyanobacteria, enters the atmosphere in large amounts and paves the way for more complex life. The newly formed oxygen in the air reacts with methane, forming CO2 and water, which quickly cools the planet. Probably for the first time, the planet freezes over, and a phase of multiple ice ages begins that lasts millions of years. 2.3 billion years ago, the Triassian begins. Many volcanoes warm Earth, and it slowly thaws again. The melting ice flushes toxic substances into the oceans, but life manages to keep evolving. About 2.05 billion years ago, during the Orosirian, a large asteroid hits Earth and creates the largest confirmed impact structure on Earth. All across Earth, early continents with wild names like Ur, Nenna, or Atlantica collide into enormous mountain ranges. In the Statherian, 1.8 billion years ago, the supercontinent Columbia forms, and from scattered uranium deposits in the ground, a natural, self-sustaining nuclear reactor awakens. Around 1.6 billion years ago, at the edge of the Cambrian, give or take a few hundred million years, the first eukaryotic cells, meaning cells with a nucleus, unite from two other cells. One of the most important moments in the history of life, even if it doesn't look that impressive. Life still consists only of single cells. Earth's crust grows thicker, heavy continents form, and the oceans become shallower. At the same time, the first fungus-like organisms stretch out their tube-shaped arms and do fungus-like things. About 1.4 billion years ago, sometime in the Ectasian, Earth's inner core begins to form. Weird, right? You'd think it should be older. But around this time, it begins to solidify into an iron crystal, surrounded by hot liquid metal. From now on, it will keep growing. 1.2 billion years ago, in the Stanian, not all that much is going on, except that the red alga Bangiomorpha pubescens may have invented sex, a big improvement to reproduction for many reasons. A billion years ago, the Tonian begins. As far as the eye can see, rock, puddles and oceans. Life is still invisible to the naked eye. It feels different to experience it like this, doesn't it? Not everyone is having a good time here. Around this time, the first single-celled predators probably appear. The dominance of bacteria ends, and the big eukaryotes plant their flags in the oceans. An arms race between microorganisms begins that creates enormous diversity. Some even invent tiny armor. 720 million years ago, in the Cryogenian, Earth freezes over again. Sure, why not? How life survived, we're not sure. 635 million years ago, the supercontinent Gondwana forms. Much of it still exists today. Wow, what's happening here? Suddenly life gets big. In an instant, multicellular organisms spread everywhere. They're still strange aliens, but can you imagine it took that long for this to happen? 539 million years ago, the Cambrian Explosion begins. We see life bursting with diversity. Ancestors of almost all major animal groups living today appear here, while plants begin to colonize land. Life finally gets exciting. But of course, right after that comes a major mass extinction that most ocean species do not survive. Plants spread across the planet, form soil, and change the atmosphere by absorbing CO2. Everything escalates. Flora and fauna adapt better and better to life on land. We get trees and forests, fish, and the first vertebrates decide they absolutely have to try this whole land thing. 359 million years ago, in the Carboniferous forests and lush marshlands reach their peak. They become the coal humanity burns today to keep warm. Everything is happening so fast now. In geological terms, life changes rapidly. About 299 million years ago, in the Permian, Pangaea forms, the last supercontinent. And after a few dozen million years comes the largest mass extinction in history, wiping out most species. Thanks, volcanoes. 252 million years ago, the Triassic begins. Oh hey, a dinosaur. We're truly in the age of reptiles now. Dinosaurs are everywhere. The ancestors of birds do bird things. Life finds a way. Earth becomes more and more familiar. A true paradise. Life thrives. Nothing can go wrong. Wait, what's that? And an asteroid killed the dinosaurs and most species on Earth. What bad luck. 66 million years ago, in the Paleogene, the continents look roughly like they do today, and mammals take the helm. Now it's our time. We're almost home. Don't blink, or you'll miss all of human history. And that's it. Earth is ancient. We are new. So new